Okay, this is a video I've been looking forward to for a while now. I'm going to be modifying a 9-volt Lego train regulator to be able to source a little bit more current. I'm going to be replacing some components inside, diodes, the voltage regulator. I have some various heat sinks I found, and we'll just see how this works. I'm not sure how much heat it's going to generate. I may not even use it that much for trains, because I'm looking for spikes of current for, when I do like the power function servos, things like that. Also have an assortment of capacitors, and I may just try a couple. I just want a little more than what's in there, but I'm not really sure. We'll see what fits in there and all of that kind of thing. I want to make it externally identifiable without really, I don't want to just put pieces on it that could fall off. What I'm going to try to do is replace this yellow connector here with a red one, because I think that'd be cool. And this is the Technic Control Center version 1. There's no power jack, and this one has some issues in the battery compartment. It probably still works, but it's, I've got several of these. This is one of the worst condition ones, at least on the battery compartment. So hopefully that'll fit. I think that'd be really cool to use the red one. I will preface this by saying any damage you do or any problems you have if you try to replicate this, you're on your own. I'm learning this for the first time, basically. I've seen 2 sources of information online of people who have done this previously. And, I'm just taking this step by step and seeing if it gets way too hot, making modifications along the way, that kind of thing. So yeah, just getting that out of the way. I'm not responsible if you do anything crazy. So yeah, let's dive into it. First, I'm going to do a little bit of an explanation of what we're doing, and then we'll start diving in and replacing components. Okay, so the circuit here is actually very, very simple, so that's the only reason I'm able to explain what's going on. What we're going to be replacing today is the voltage regulator. This is a LM317, and it is able to source about 1.5 amps. I'm going to be replacing it with an LM350 voltage regulator, adjustable voltage regulator. This one can do about 3 amps, so that'll help things a lot. We have 4 diodes here, and that is the bridge rectifier. That is what is going to, so this is the adapter that comes with it, and you can see this is AC voltage. So a bridge rectifier is just an arrangement of 4 diodes, and that converts the AC to DC current. And this is the capacitor that we're also gonna try to beef up a little bit. And the way that it works is, again, very simple. You've got the input, and we've got all these resistors here. So whatever step this is on, the higher you go on the speed regulator, the more resistance there is, the more resistors it has to go through. And then we've got this formula here, and I actually did double check, these are all correct. So you add all the resistance together, divide it by R2, which is here, add 1, and then multiply by 1.25, and then these are going to be your output voltages. And if you'll notice, these are tied together on the left and right. And that's because this is only for the speed, and there's actually a second set of contacts, and we'll get into it a little bit once we take it apart and look inside. And that just determines the direction. If it's on this side, it's going to be one direction. This side is going to be the other direction. And then from there, it just goes out. This is just the motor and everything like that, and your track. So that's the whole circuit. Very, very simple. And shout out to Mark Bellis for drawing this up in 2005. So it is currently 2022. So it's been a little while since then, 17 years, but very appreciative of all the people in the Lego community that do this kind of thing. That's awesome. Okay, so now I've got the screws taken out. It's just 4 Phillips head screws. And then the connector here just pops out of the top there. We'll pull that out of the way, and then this is what we're left with. I believe there's at least 2 internal revisions of this board, probably more than that. And it shouldn't really make a difference with what we're doing here. I would imagine they all use the same components. They may be laid out in a slightly different way. PCB may be a different color or something like that. Again, those kind of things may pop up in a follow-up video. If I do a follow-up video, I will post it in the description of this video. So this is our capacitor that we're going to beef up a little bit. This is... Oh man, I got... Okay, so watch out for the grease. That's all around here. Let me get a paper towel. Okay, should have saw that coming. Stupid. All right, so this is our LM317. It has a pretty dinky heatsink. It barely even feels like metal. So that's going to be getting replaced. 4 of these diodes will be replaced, and I've got to look and see which ones are which. And here you can see this is how the contacts are made. You've got these little jumper plates here, and they turn around the dial. So all of these are your speeds, and then the ones on the inside, that's what determines the direction. So very simple circuit. Not a whole lot that can go wrong with it. These voltage regulators have short circuit protection and overheat protection. They will just shut down if they get too hot. So that's great. That'll make it easy. See how things go in the future. And if you have one of these that you hear a rattling sound inside of it and you've never taken it apart, it's probably this clip. I have seen people say it's a little bit prone to just popping out. Yeah, so comes off pretty easy. And I'm trying to see, this is, yeah, it's got a double-sided adhesive pad that holds it on there. And what I may do is just put another heatsink on the back here. I'm not really sure. We'll get there when we get there. So now that we have our board, we're going to start cutting components because that's the easiest way to get them off, and then pulling the leads out. Where did that clip go? Okay, so I did notice, at least on this version of the board, which maybe some of these numbers mean something, or these numbers, and yeah, we're getting this wire I'm going to replace because it's the same wire that they use in all the other stuff, so it's disintegrating. It's had it pretty easy because it doesn't get bent inside of there, but if you were to, you know, keep playing with it, it's all this is going to flake off, so that's going to be replaced. But there's no these components aren't actually designated on printed on the board, like you know, well actually they're not here either, but R4, R5, these are have a number for them, but best I can tell, looking at the back here, this is the power input, and it goes straight to here and straight to here. So it's going to be these 4 diodes. Obviously, that's what's going on. So these are what we're going to replace, because there are 2 other diodes. There's a diode across the regulator here, and then one across the terminals there. And then, well, light emitting diode, that's a diode. So now we know what we're going to do. And again, this is the easiest way, especially for this guy. The easiest way to get this out is to just cut the trace, to cut the pins. And the reason I do that, I mean, I've done a lot of repairs on like pinball boards and boards that are old and fragile, with fragile traces, things like that. And if you just start heating these up and pulling, it's very easy to damage the traces or to pull, you know, this top part off here. So we're just going to cut it out. Just like that. That's not exactly very elegant, but and that actually make it a little bit tougher to get out. No, well, it'll be fine. And I'm going to do the same on the diodes. You really only have to cut one side. And I guess we'll do the same for this guy. We can just put the capacitor in parallel, but I'm not sure. I'm going to have to see how this is all going to fit inside the casing. And I guess this isn't marked, so yeah, I forgot about that adhesive pad. All right, now I keep getting this stuff all over my fingers, this grease on the back side. So I'm going to straighten these out. That'll make it much easier later. Okay, hopefully this stays in focus and everything. I'm a bit of an amateur, guys. Just deal with it. Okay, so it's the top set here. And first off, I'm just going to apply some fresh solder. Depending on when it was manufactured, it probably has the lead-free garbage solder. Supposedly safer and all that, but it tends to dry out and crack easier. Easier to get a bad solder joint. And where's the capacitor? These big ones here. All right. Clean that again, and then do some fancy solder work here. So I'm going to heat it up, pull the diode out, and it looks like the negative band is going to match these other two diodes. It's always, before you even start, I would take a picture of the board, just so you can see later the polarity of things, because this isn't, you know, normally on this side we would have like D1 through 4 for these diodes, and it would have a picture with the band of which side is negative and all that kind of stuff. But this board doesn't have any of that. It's a little disappointing, but I mean, I guess I didn't expect people to be doing this kind of stuff. So yeah, I'll just keep going around the board here and pulling these out. And just to reiterate, to not damage these pads, you're heating it up, letting it become molten, and slowly, you can kind of jiggle it a little bit, but don't start just pulling out before the solder lets loose the component. That is how you damage traces. Again, these look fine. They're probably going to be okay, but just a tip for electronics repairs or modifications. Okay, so we're back at it again. I lost some footage there. Had some issues. This is actually a few hours later. Let's get back to it. I wanted to show this, and this is something a coworker made for me. This is what we use when we're trying to work on boards like this. This is a sewing needle, like it's stainless steel, whatever. I don't even know how he makes it exactly, but that's how, you know, these holes, notice you can see through them, and that's because I've used the needle. So just to show that, I'll close one up. Okay, so now this one you can't see through it, and all you do is find the right hole first, and then I just kind of hold the board like that with the, not putting a whole lot of tension on it yet, just lightly holding it there. And then we'll heat up that pad, and it'll come right through. and then you can just kind of work it around, and now you can see right through it. So now your new components will slide right in. You won't have an issue, shouldn't have an issue. And that's definitely going to come into play here when we put the voltage regulator in. Okay, so I'm going to start slotting in the components. So let's get our new LM350 variable voltage regulator. And these were pretty cheap. It was basically like a little over $10 to get like 10 of them. Yeah, that looks about right. And with this, I'm just gonna use some of the solder that's there just to get it into place. But I'm gonna put new solder on all the terminals. Okay, so that looks fine. It doesn't have to be perfect. Go ahead and snip off that too, actually. All the extra bit here. Yeah, it's a little crooked. It doesn't really matter. Okay, now we've got our diodes here. Oh, I'm drawing a blank on what the actual current rating is on these. The originals were 1N4002, and I'm going in with 5.4. That's not going to focus, is it? No. These are 5406 diodes. And again, they do match these other diodes that stayed in here. So we've got the negative band is going that way. And these are a bit overkill. Like I said, I'm just using what I've seen others use. And I'm just using my needle to kind of make a little more space in here. Okay, so I'm finding out these are very tight. Just the sides of the leads on these, it just barely fits in these. So this is going to be a real pain. I don't think I have a reamer tool here. These traces look okay, but it's definitely very easy for this trace to just break away, and then you'll have to do some other stuff. What I could have done is left the old bits of the old diodes and soldered directly to those leads. That would have been easier if I had known what was in store for me here. So I'm just using one. Got it through. To make sure these are going to size up. Okay, so I'm not sure if this was in the bit of footage that got lost or not. This is a solder sucker or desolder pump, and it's just a vacuum pump. And I'm not always a huge fan of using these, depending on what you're working on. In this case, it should be fine. But like I said, these holes are just so tight, and there's just little bits of solder that are going to make it impossible to get those leads through. So I'm actually going to add more solder to make sure I get all of it in one go. Okay, moment of truth. That is ridiculous. Well, I got one side in. Come on. So with these, maybe I should have went one size smaller. Again, I just went by what they had built on the video that I watched. I may actually leave it like that because it lets it not get quite as hot when it's not just sandwiched onto the board and right next to other components. This gives it a little bit of room to breathe. We just want to make sure it doesn't short out against anything else. Well, I'm calling that good. And just to make sure everything fits right. Yeah, I want to make sure these weren't bottoming out on the plastic here. That looks fine. These things are so big. Alright, looks good enough. And looking at this capacitor, I didn't even notice this earlier. This is a 25 volt, 2200 microfarad. And it is from Japan. Japan usually where the best capacitors come from. But I didn't notice this is only a 16 volt. I'm going to go ahead and use it. It is what it is. In the video I watched, they use a huge capacitor. I don't think it really needs to be that much more. But again, it's something I can always change later. And again, this is a different package type. So this is an axial capacitor, so it has leads on both ends. And I can't remember what this is called. Canister, something, I don't know, but you know, both leads are there. And from what I remember, this is the positive terminal because it goes right over to the voltage regulator, this connection here. So the negative is going to go on this side. And of course, the longer lead is the positive lead. It's always a little bit longer, or should be at least, if they follow standards, if they're not monsters. And if you were wondering, something I thought about earlier, you've got all these resistors, and you might wonder, where are they? And it's actually this guy right here. This, I forget what these are called, a multi-resistor package, something like that. And you can do capacitors like this too. There's a common ground that's marked. And then from there to pin 1's, what is it, 463 ohms. Ground to pin 2, 463. Ground to there. Each one of these is one resistor of 463. And then again, they all terminate with the same ground. So that's how they were able to save components on here. I really should have thought this through better. Yeah, something like that should be fine. And what I'm going to do now that I've got it bent the way I want is I'm going to put a little bit of heat shrink on each of the exposed leads there. Yeah, something like that. This is definitely something I've had to do on pinball boards. Yep, okay. And again, I'm probably just gonna melt what solder's there to hold it in place. That actually looks fine. I'm probably not gonna worry about using fresh solder there. Okay. Now we've got our clip, which is probably going to go flying off. See if I can get it in there. Okay. And again, I do want to do a little better with a heat sink, but I'm probably going to do that later. I want to see how hot this gets compared to an unmodified one, and then I can try a heat sink and see how that helps. Now I'm just going to replace this wire, and then I'll go upstairs and test it. I'm not sure if that's going to be part of this video or not. This is obvious. This is going to have to be cut into a few parts because it's taking quite a while, but we're just going to do assembly today, and then I'll kind of test it, I guess, in the morning. And again, this is just going to be the donor. I'm going to try to pull this red piece out there. Okay, so just 3 screws on this one, and this lifts up like that. And you can see, okay, these are different type of insulation. This is the kind that's should be fine. So I'm just going to pop these out. Oh, it's been so long since I've done this. Yeah, there we go. This whole piece comes up like that. And then we can disconnect the battery terminals here. Get that out of the way. And yeah, yeah, this is just sitting in there, so if you let this fall out, all your buttons and everything's gonna come flying out. Okay, so I'm going to make sure this stays just like that. I'm putting all that back together. And this is what it looks like on the inside of one of these guys. I was wondering what it would take to upgrade one of these, but it looks like it'd be much, much more complicated. I'm not even sure, because these don't seem to be able to source much current when I was playing with them. But it is what it is. The red connector is the one I want. And since they've already got these nice little metal connectors on there, I'm just going to try to desolder these. Just going to add a bit of fresh solder. On each terminal. Oh, it's getting hot and it's not wanting to come out. Okay, there's one. There's two. Isn't that cool? This is going to be awesome. And it looks like it's, it should go in there fine. I was worried about taking this connector apart because you can kind of tell it's a little different because it's got these two holes there. Yeah, you can see here, this is much different than the normal connector that I'm used to repairing. So I'm not going to bother with that. But because it's like that, it generally has the other type of wire. And again, I'm just looking at the polarity here. So this pin's going to go there. So we'll just pull one of these out. And this is another tip. Before you pull both ends out, let's get the polarity right. So that's the one we pulled out. That's the one we're putting in. And now we know we have the same polarity as before. But I'm always going to double check 10 times. Yep, we got it. We got it. we got it. So that's good, you know, just thrown together. But I'm gonna go ahead and completely assemble it like it is, and just kind of play around with it and see what I can find out. I hope this wire is long enough. I was so dead set on getting the red that I didn't. Yeah, that's fine. Another pro tip, don't lose the screws. What did I do with them? Okay. There's my power input. Let's see if we let the magic smoke out. And we've got an LED, so that's good. Now, I'm going to move some things around and get my multimeter and see what kind of voltages we're getting on the output side. Okay, look at this monstrosity. So this is my 12 volt power supply that I built. All it is inside is just a transformer and then a distribution box on the front. I've got these two terminals here that allows me to measure current on the AC side. This is volts AC, so it's 14.3. So again, the capacitor I ended up using was only rated at 16 volts, so maybe I should jump up to a 25 volt. This is volts in coming from the regulator. So we've got our light on, it's turned on, and you can see how the steps work. So we got 3 volts, 4.24. So that first step's bigger than the other steps. 5.47, and then it ends up going all the way to just above 9 volts and back to 0. And if we go in the other direction, we have negative 9 volts. So we know this is working as intended, but again, we've got to go further. I want to see, I'm going to put some kind of temperature probe on the heatsink for the voltage regulator. I'm going to be, you know, setting up with a bunch of meters and just trying to see how it's going to work. I might set up a train layout and maybe do a dual motor locomotive with, you know, 2 9-volt motors, and just really test this out, because I've seen people use this, but there's not a whole lot of information. Again, I'm going to link the stuff that I've found. There's one video where he has one already built and he just kind of shows the inside of it, and that's where they identified all the components that are inside. And then another one is a Twoloosebricks post. It's a really cool project this guy did. He's got, like, I think 4 of these that are modified, huge heat sinks on the back, and he's running a lot of currents. That's why he did all that. But in my case, I'm really just testing it for the fun of it, and just because I am making a video about it. But, you know, I use these to control, like, infrared receivers for my power functions. So I'm looking to absorb spikes of current to make sure these servo motors work correctly, all that kind of stuff. So that's it for now. So look forward to part 2. You don't want to miss it.